and welcome. For my second practicum project, I thought I could delve into the relatively new world of text generation. My project is called Vinobot, Automated Wine Reviews. Let's get to it. Um, wouldn't it be nice to be able to solve an existing challenge in a practical manner? When I mentioned my chosen scope, my sister asked if it was possible to generate short banners in the style of banners of best performing products. She leads a software engineering team of a marketplace app where hosts and guests are matched for service. Thus, she's always interested in features that can aid new hosts build their profiles with efficiency and increase their bookings. Banners are free text short sentences written by the hosts to pull attention to their products as guests browse the app. Advertising is the backbone of sales, as you know. There are some products in the marketplace that are favored more than the others, and one way to influence this is via banner ads. In some cases, the users may either be blown away by the offer or turned off by it. But what if you had a template for the winning strategy that you can slightly alter for the masses? In banner words, you could increase sales if you could theoretically replicate the style of writing of the top performers, right? Well, I thought the same applies to wine reviews, which I chose it as my dummy set. This study aims to create an automated content generation system to assist human writers and make the writing process more efficient and effective. The name Vinobot Wine Club only makes sense to me as the title, since my mission is to imitate a sommelier and generate wine names, varieties, and perhaps even short reviews. Since the data for the banners was not currently available, I thought I can use wine review data instead. And do a series of proofs of concept to deepen my understanding of what's possible in text generation. I wanted to use a clean data set that allows me to concentrate my time on text generation portion rather than the data sourcing and prepping. Recently came across to a series of Twitch videos on graph databases, and the presenter was using this particular data set, and I will be using the same data set as my source. It's a modified version from Kaggle, and it was scraped from Wine Enthusiast in 2017 specifically for text analysis projects, which is perfect. Although I started out with a curated dataset, there were still a few things that could have been done. And one of my goals in this project is to show data visually, right? While browsing the pandas docs, I came across this cool function which takes a scalar and returns a string with a specific color. I think it produces a very easy to consume chart for total numbers of missing rows and its percentages. Next was imputing missing prices, and I thought I can gain information by looking at the interquartile ranges of the wine prices. I like Boxlot. I always feel like I get so much information for very little amount of work of creating the chart. Um, but I was almost fooled this time by the uniform distribution of Switzerland's wine prices. Boxplot, by the way, shows country versus price. With a medium around $35 and no outliers, it looked like the dream subset base price to impute on, right? But I was incorrect. Once I count the number of reviews, it is actually easy to see the root cause of the uniformity. Switzerland has only 6 out of approximately 120,000 wines in the system. As an output from the explanatory phase, I decided to pickle my dataset. This particular sentence actually changed my mind. I have been using export to CSV without an issue for some time now. It did actually work out great for my needs. This curated dataset is also available in project's GitHub site. Now, natural language processing, right? I always kind of thought it's an interesting subject because most of the machine learning techniques are tuned to work with numerical data. Right? And besides my normal infatuation, I have been noticing a significant increase in my Medium inbox with articles stating how transformers and pre-trained language models are so much more superior than the more traditional techniques such as RNN and LSTM. So I used 4 methods in this project to generate text. These were recurrent neural networks, long short-term memory, sequence to sequence, which I'm going to talk under LSTM, and generative pre-trained transformer. Recurrent neural networks are called recurrent because the algorithm performs the same computation for every element in the sequence, right? The inputs, outputs, and the states are represented by vectors, and the way it works is it generates the next character, given the current one, and keeps the history. My goal was to generate wine variety names from scratch, and since RNN works character by character, I thought I can get better results if I only tried to generate a short single word text, and I was right. I did three main runs with 200 epochs, 2000 epochs, and finally 5000. I know the number of epochs is not that significant. More important thing is the validation and the training error, and as long as that keeps dropping, the training should continue. Therefore, I watched my training, and I did reach the diminishing rate of return at around 1500 epochs. As I said, character generation is straightforward. You initialize the first character in the sequence, calculate the probability distribution of the next probable second one, and then you repeat until the desired outcome is reached. And I think the results can be pretty valid for new varieties of wine. These were some of my favorites: Massi, Sirigaz, Chara USSA. And then there were some funny ones such as Chardonnay, Melot, Pilot. And perhaps we can even combine the names, and I'm sure I would be interested in a glass of Melot Pilot. My girlfriend also thought it was a cute wine name and said, "You don't want a stressed out pilot, you want a mellow one. When you go all out, you order a flight." All right. Moving on. Now, when it comes to treating input sentences that span longer intervals, there are limitations to RNNs, and these limitations, namely, are vanishing and exploiting gradient problems. During the project, I spent majority of my time preparing and training the datasets for the LSTM networks. Here, I'm presenting the code where I removed the variety list of wine from my corpus in order to remove the special characters. Plus, I did not want a review say, this Chardonnay feels jammy. For these reasons, I thought removing the variety list from the corpus would work better during training. Created the LSTM model in Keras. I compiled it using categorical cross entropy for loss, and Adam is the optimizer. You can see my LSTM1 network and then the dense network right under. My first proper run was with 20 epochs. I realized I made a mistake of removing all stop words from the corpus. The results were more gibberish, if you can believe it, than this. So I ran it again with 20 epochs. I still, again, used the clean version of the vocabulary, meaning I effectively updated the foreign letters to English ones, but perhaps in hindsight this was the issue. Perhaps I needed to keep the integrity of the corpus. And then finally, my third and final run was really to test if training speed is directly related to the processing power. For this reason, by the way, I have been only working with just the 3.7% of my entire corpus because of processing reasons. Although I tried with the massive machine, I was not able to get coherent results. But the entire job did finish under 2 hours, shaving off an entire hour. Then I saw examples where training was being done for 500 epochs to generate much shorter sentences. I decided for these reasons, using 20 epochs is not going to be enough to create a complex model. And in order to produce coherent generated sentences, not only I had to use my entire corpus, but also build a much more complex network. Before I continue with GPT-2, let's talk a little bit more about the root causes of fails in LSTM. Now, most state-of-the-art NLP models were trained specifically on particular tasks like, say, sentiment classification using supervised learning, right? But supervised learning has two major limitations. One, they need large amounts of data, large amounts of annotated data for a particular task. This does not usually happen or exist in specific domains, right? There's an entire industry built around this for data labeling and annotation services. Two, they fail to generalize for tasks other than what they have been trained for. Why? Because The raw data, when it's stamped and lemmatized form, each word has its own meaning. However, it lacks the semantic relationship when it's put among the entire corpus. So, in an ideal world, there will be a universal model to represent any embedding in a vector space with minimal feature engineering. Here comes the transformers. BERT was the first model I looked into. It's not suited for my needs. Apparently, BERT and all BERT variants are not autoregressive models, meaning they cannot generate text. Luckily, GPT-2 is autoregressive, which means developers must out future time steps so that the model can predict the next word from left to right. The G stands for generative. It means the model was trained to predict or generate the next token in a sequence of tokens in an unsupervised way. And the integer 2 means this was not the first time this was tried. I use both 117 and 355. Process is straightforward when you use a wrapper called GPT-2 client. It is possible to generate some results with a few lines of code. And this time I use a standard machine with a single Tesla GPU, but with a P100 instead of a P80, which is slightly faster. Here we are. After loading the saved model, the 355M, I can now generate text from trained model. One thing I need to mention is the include prefix. I did add the prefix of this wine is. In hindsight, perhaps this was not necessary. I could have gotten as good, if not better, results. I feel the prefix is kind of affecting how the next word is in the sequence. But overall, I think this is a success. The fourth one from the top is the winner in my book, but none of these reviews read like they were generated artificially. I bulk generated a few lists with variations, and these are available on project's GitHub site. Now, let's talk a little bit about future works and final thoughts. Ideally, this app would be able to write like any one of the staff at Vine enthusiasts. Perhaps one way to do this would be to train the fine-tuned result set using a taster-specific data set, right? It would also be better if a type of variety can be included in the choices. I would like to review Chardonnay like Jim Gordon, perhaps. But there are currently 708 unique varieties in my wine list, so perhaps I can use BERT for topic modeling first on wine reviews, and then recategorize my data set to a more manageable number. And finally, I think the reviews are like short poems and in some cases resemble a haiku. I also think when they rhyme slightly, we're not really writing song lyrics or drunk reviews, it sounds more human. I would be interested in seeing how training with Project Gutenberg Poetry Corpus would affect the results. Transformers really may be the missing link that enables computers to actually understand language and its context. After working with GPT-2, I can assure you that GPT-3 is going to be marvelous. It's actually released last June and currently in private beta, but I also read that Microsoft teamed up with OpenAI to exclusively license the language model. And finally, I believe sustainable business models are built upon democratization. I think pre-built NLP libraries can aid this cause by allowing rapid access to experimentation. Thank you.